this year's lineup of speakers is the best yet. Every year we get better and better and better because the content is getting better and better and better. Shortly, I'm going to announce our keynote, but before that, I just want to describe some of the things that's on your program. You should have received this. This has all of the links. The blue are the links. So if you hit those links at that time, then it will take you to the presentation. So just keep this handy, and then you can just click those links to go into those presentations. So please keep that in mind. If you look here, we have so many great things happening from the speakers, from our forums, insurance forums. We have folks here from the FDA. Our lineup of keynotes is just out of this world. And the Innovation Challenge, the 7 teams that are the finalists, we will talk about them later, but they are amazing. You will see videos produced by all 7 teams, and then you will have an opportunity to vote for fan favorite. So keep that in mind. Now, this year, we introduced something really cool called Brella, B-R-E-L-L-A, Brella. You received an email yesterday with instructions on how to link in, sign in to Brella. Brella is super cool application that allows you to network. So what you do is you go in, you sign up by, I think you got to input like name and address, email address, and you sign up. You click all the areas that you're interested in, and Brella will match you to other people with similar interests. Or you can go down the list of all the people who have signed up on Brella and all of the speakers and all of us who help to run WERA, and you can click and request a meeting. It is such a cool, simple application that allows you to network. So sign up for Brella, tell others to sign up for Brella, because it is an awesome way to network. And we know that is one of the reasons why you come to events like this. The last thing I wanted to note is that we cannot do this without our sponsors. It is because of them, we are able to host something like this. So I really want to thank our gold sponsor, Angel Robotics, our silver sponsors, Anybody Technology and HeroWare, our bronze, Ottobock and Comau, our Innovation Challenge sponsor, Fit Scientific, and our virtual marketplace and spotlight demo sponsor, the WearTech Center. The WearTech Center is this. This is a Arizona State sponsored facility where WERA and GoX Labs lives. And so I want to thank them. And then obviously our annual sponsors who helped us to get from last year to this year. So thank you all so much. And one last thing I do want to acknowledge our association conference group who help us to manage and run these conferences. So Amy and Meg, they led the effort. So if you see them in chat, please say a hi to Amy and Meg from ACG, who helped to really put all of this together and orchestrated all of this. Some housekeeping notes. Again, most of the events have separate links, and those separate links can be found on the agenda that was sent to you. Here in blue are those links. So link into that and it will take you to the presentation. Once you're in the presentation, at the bottom, you will see a chat box. Use the chat box to input your questions. So again, the chat box, use that to input your questions. At the end, the host of the session will read those questions and look for a response from the speakers. So chat box, input questions. The other thing that we're gonna do is, because we have so much awesome stuff packed into the next 2.5 days, the events have to run boom, 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 back to back, exactly on time. So that's exactly what the hosts, the moderators, will make sure that happens. The other thing that I do want to mention for today is that we do have a spotlight demo by our gold sponsor, Angel Robotics, right? It's been a while. I wonder what Angel Robotics is up to. So I'm very interested in seeing that. And then WearTech Center has a demo as well. The WearTech Center here has been working on exoskeleton testing protocols, and they want to show you that. And then finally, at 4:30 p.m. Eastern Time, join us for the happy hour. It's our virtual happy hour. I will have a stein of beer with me. I'm going to change the locations. It's going to be outdoors and it's going to be fun. And join us for that virtual happy hour at 4:30. We're going to come together, break up into small groups where you're going to have discussions about some of the questions we're going to ask you. You're going to come back to the large group. We're going to answer those questions and talk to each other. And then you're going to break up and go into small groups and talk about things. And some of the questions are going to be fun and silly, and other questions are going to be hopefully insightful. And then we're going to come back as a group. Last year's virtual happy hour was an absolute success. So please join us at 4:30 Eastern Time for our happy hour. Okay. I am actually 3 minutes ahead of time, but I'm going to go ahead, introduce our keynote. And what Norm asked was for me not to read the bio, which is incredible. Instead, I'm just going to introduce Norm with one sentence only. And here I go. So Norm, I'm going to go ahead and do the introduction. We're 2 minutes early, which is a good thing. So Norm Bafunno is a senior vice president at Toyota North America. And he is responsible for all unit plants and unit production engineering in North America. We are so honored and thrilled to have Norm kick WearCon 21 off. As we know, Toyota is a leader, an early adopter of exoskeleton technology and this type of wearable innovation. And so it is absolutely appropriate that he helps kick WearCon 21 off. With that, let me turn it over to Norm. Norm, please.
So good morning, Joe, and thank you very much for the nice welcome. I know it's virtual, and you did a great job kind of introducing the conference to us all. I'm very excited to be here. I'm very honored to be here as the speaker today on behalf of our Toyota team from North America. A minute ago, you heard this unit title. What does that mean? It basically means I am responsible for our powertrain configurations of our vehicles, hybrid, internal combustion, and then all the component manufacturing that makes that up with our aluminum blocks and heads and things like that. But I'm super glad to be here, and I'm very excited to share some of the work that we're doing with wearable robotics. I will be using my index cards to march through my slides with a little bit of help. But I want to tell you that I'm here today live from our North America headquarters in Plano, Texas, brand new. Today I'm on site though with only probably 100 team members. Our site has capacity of over 4,000, but because of the pandemic, obviously we're working from home and flexible work arrangements right now. I've entitled my presentation today, Wanted Smart Wearable Robotics. Now, to get started, I would like to share a quick introduction of myself to you, created by one of our engineers who's also a graphic artist. Growing up in St. Louis, Missouri, I quickly became a Cardinal baseball and Blues hockey fan. After high school, I headed to West Lafayette, Indiana to complete a bachelor degree in mechanical engineering at Purdue University. My career in automotive began at GM, where I worked at several plants in Michigan and in Wisconsin. Along that journey, I earned a Master's of Management degree at Northwestern University in Evanston, Illinois. I joined Toyota as part of the original 30-member startup team at TMMI to create its future. I was proud to launch a brand new vehicle, the Tundra, and win JD Power #1 in its very first year. That had never been done before. My key learnings at Toyota have focused on the application of the Toyota production system and Toyota problem-solving skills. Career moves to Erlanger, Kentucky, supporting the North American production engineering team, and to Plano, Texas, creating the competitiveness team, and now supporting the North American powertrain team, have all challenged me and helped me to grow. I met my wife, Julie, many years ago in St. Louis, and we are proud parents of 3 grown children. I am Norm Bafunno, Senior Vice President, Unit Manufacturing and Engineering. You know, at Toyota, we start each meeting with our personal safety commitment. Mine is I will follow all 5 Toyota safety behaviors. This creates really a visible individual accountability towards safety. My presentation today will cover these 4 topics. First, I want to give you an overview of Toyota North America. Obviously, our marketing team knew I would have all of you here joining today, and I wanted to share a little bit about what we have done and what we're doing today. Next, I would like to cover and define our safety activities, our culture and focus. I have data that will cover both how we have used wearables and some video to actually show and demonstrate the activities. And then I would like to throw out some challenges toward the future. Now I will start with a brief update on Toyota North America.
For most, the American dream involves a lengthy journey, a hopeful and optimistic trip along a far-reaching road. For Toyota, the journey began in Hollywood in 1957, when we opened up in an old Rambler dealership. Over the next year, as NASA first started to reach beyond the sky, we broke into the US market, selling Toyo Pet Crowns and Land Cruisers. Well, we sold a Land Cruiser. One. Throughout the 1960s, our success steadily grew. And in 1972, as the Sears Tower was being completed in Chicago, we opened our first manufacturing plant in the United States. We built truck beds in Long Beach. In 1973, we opened Calty Design Research in the epicenter of car culture, Southern California, hiring American designers and studio engineers. In 1977, we continued to invest in America's creative and technological spirit, establishing a research and development facility in Ann Arbor. In 1986, the year of Hands Across America, we took the first step toward making cars in the U.S. and broke ground on Toyota Motor Manufacturing, Kentucky, which is now our largest vehicle manufacturing plant in the world. In 1988, what we were imagining in Michigan and California, we were building in Kentucky. And in 1989, we disrupted the luxury market by launching Lexus in America. Since then, our cars and trucks, and their parts as well, continue to roll off the line in plants all across the USA. In 2000, Y2K never happened, but the new millennium did, as we introduced the first mass-produced hybrid car to the world. We have remained on the forefront of zero-emissions technology, investing $1 million per hour on R&D globally to help create a cleaner and healthier world. In 2017, when coast-to-coast totality occurred for the first time in a century, we transitioned from a group of dedicated affiliates across the country to become one united Toyota. Our team members are now collaborating more effectively, responding to market conditions faster, and serving our customers better. Most importantly of all, we have been dedicated to improving the lives of American families and communities, with nearly $1 billion donated to nonprofits across the United States, funding disaster relief, environmental programs, mobility solutions, safety, and education. Looking forward to 2020 and beyond, Toyota expands its vision beyond automobiles towards a larger idea of mobility for all. While holding steady to our unwavering focus on safety, we will continue to harness technologies that create better ways for people to move, whether that is across town or across the room, on the open road of possibility.
At Toyota, our vision is to lead the way in the future of mobility. We want to create a new and better way for people to move around. Some of you may know that Toyota was actually founded as a manufacturer of automated looms before we started the manufacturing of cars and trucks. In that same transformational spirit, we are now becoming a global mobility company. While we continue to make great cars and trucks, our commitment to mobility goes beyond vehicles. Emerging technologies give us the opportunity to do even more to help people get where they need and want to be, and to help people experience the freedom of mobility. As part of this effort, our global president, Akio Toyoda, issued a challenge to all of us: start your impossible, a global call to action to make a difference and to inspire us to defy the impossible. You know, it is part of our culture of continuous improvement and respect for people to encourage everyone to contribute, whether from the shop floor, from our headquarters, from our dealer network, from our engineering lab, or even our field offices. We want everyone to think outside the box, to challenge the status quo, and to share any idea. None are crazy. This is an exciting time for us to reimagine Toyota for the next 100 years. You may be asking, why is Toyota here at the Warecon 2021 conference? Simply to learn from you, the innovators, the creators, the testers, the evaluators, and even the users. We appreciate what you do, and we appreciate what you have created. Your solutions help us in our manufacturing processes. We have been part of this Warecon activity for more than 4 years. Marisol Barrero, she is a manager of safety innovation at Toyota and a member of this activity. And she was co-founder of the Automotive Exoskeleton Group. Our footprint in North America is vast. We have operations numbering 14 across the US, Canada, and Mexico as shown. Our headquarters with the star is in Plano, Texas. The blue circle is our production engineering team located in Georgetown, Kentucky. And 70% of the vehicles that we sell are made right here in North America. Safety at Toyota is our #1 value. It's our #1 priority. A strong safety culture is a fundamental part of the respect for people principle. At the entrances to our plants are safety reminders. They all reference safe work is the door to all work. Let us pass through the door. Also, we collect safety feedback at the end of every shift from every team member. It could be a stiff tool, a part issue, something of discomfort. Shown here is the question we ask. It's how's your process? As the team member clocks out each day with their badge and they scan it, they have to push one button, a green button or a red button. The green button means no issue. The red button is I have an issue, and it alerts the group leader. So the next day, they can have some discussion to resolve issues. This kind of an activity is a reactive one, and we want to make it more proactive in the future. This brings me to the safety technology roadmap that we've been following for a few years. It's reactive, it's predictive, and ultimately, it's proactive as well. In the early phases, we were reacting to the need for technology in cranes, powered industrial vehicles, and emerging technology trends. Next, in 2019, we began utilizing the technology to enhance safety. And since 2020 and now in 21, we're attempting to have a systematic implementation of the technology, and we still have much work to do. Now, I will discuss why we are adopting wearable robotics at Toyota. Shown here is a pie chart summarizing the discomfort during the past 20 years from team members. And you can see concerns about arms and shoulders, legs, hands, and back. You know, to countermeasure these activities, we've been deploying engineering controls, but it's not enough. And we've also been deploying wearable robotics. I will focus on two specific areas, starting with hand exoskeletons. You know, we've introduced training on hands and wrists for fatigue, training on the proper gripping of tools, not to overgrip with force, even how to trigger with the right appropriate force and the right finger, proper wrist positions not to deviate, but it's not enough. So if we go back to the pre-COVID-19 activity, we began trialing hand exoskeletons. And you can see why. They're active powered devices for the hand. They're worn alone or under a required glove. They assist while performing grip and intensive tasks, and they may reduce the discomfort and injuries from repetitive overgripping. Now, when we were searching for a hand exoskeleton solution, BioServo Iron Hand was the sole one that we felt was ready for testing. So we trialed it at our Kentucky plant. The trial included 8 team members for 10 days. The team member shown here is in our body weld area, and he is actually responsible for installing the doors. So first we have to install the hinges, grab some bolts, tighten those down to the appropriate torque, bring the door over with a jig, set it in there, put it in position, pin it in place, and we're off and going. But one note, the team member also, with the yellow arrow at the bottom, is required to double glove. In our body weld area, because of the metal panels that are stamped, we require a cut-resistant Kevlar glove to fit over the hand exoskeleton. Now for the results of this trial. You can see on the right-hand side the values of how we improve. The dark bar shows the without the Iron Hand application, the team member feedback about discomfort. And you can see afterwards in the light blue In every application, we saw improvement. And it actually came down from the action limit line in a couple of cases. On the left-hand side, you can see the scale that we used. It was part of the American Congress of Government Industrial Hygienists, 0 being really good, 10 being really bad. Okay, next. I would summarize this trial saying that it was encouraging and it provided value. But the key issues that were there still remain. The backpack that powered the device was a little bit heavy. The dexterity, because of wearing double gloves, was impeded a little bit. The finger motion of the device sometimes maybe stuck, sometimes wouldn't activate. However, overall, I want to say we have very high expectations. We were very encouraged with the results, and we really appreciate the collaboration with BioServo, Iron Hand, and the team. They were very positive, they were very responsive, and we're going to continue trials with the next big one coming up this summer. The next area I will review is the area of the arms and shoulder exoskeletons. Arms and shoulders come first as the most prevalent discomfort reported by team members, as you can see here in the pie chart. Pictured is a team member fitted with an exoskeleton installing plugs on the underbody of our vehicle in the paint shop. It's a great application. At this time, we have deployed more than 500 shoulder exoskeleton devices across our operations in North America. Importantly, we have collected comments from team members wearing those devices. And as with the BioServo Iron Hand, we are challenging to find positive, measurable impact of these devices. For example, in collaboration with Iowa State University, and thanks to Dr. Jason Gillette, an electromyography study was developed to look at muscle fatigue. In general, team members reported greater comfort and less exertion when wearing these devices, correlating with the EMG results. The timeline below shows the steps we have taken from awareness, trial, systems, now becoming PPE, personal protective equipment requirement, and then the maintenance of that activity. This is an actual workplace in one of our plants showing a placard with the exoskeleton required PPE. So just like safety glasses, safety shoes, hats, maybe gloves, the exoskeleton is required in these processes. Now, we had to do a lot of work to determine when an exoskeleton would be required PPE, and we followed the actual arrow on the left-hand side of Gates in order to derive this outcome. Next. I think it is best now to hear some verbatims from team members in our plants about what they think about these wearable robotic exoskeletons.
Toyota believes that mobility goes beyond cars. It's about overcoming challenges. The Start Your Impossible initiative highlights the company's goal to provide mobility for all. Just as we are developing mobility solutions to help everyone enjoy their lives, we are developing solutions for our team members to work in better comfort and enjoy greater mobility at the end of their day. Since late 2016, we have been trialing exoskeletons across multiple Toyota sites. We are seeing significant design improvements in the workability of these exoskeleton devices. We found that team members generally report less discomfort and effort while wearing the devices.
What I've been doing is when I first started, my shoulders hurt really bad and my hands hurt. And honestly, I thought, I can't make it. Like, I'm not cut out for this job. Through a lot of fine tuning, and a lot of finagling, we got it to where my shoulders don't hurt at all. My hands surprisingly don't hurt. My back doesn't hurt. Honestly, I think I could work all day.
Been wearing the exoskeleton now for a little over a year. One of the biggest benefits I see for myself is I don't have the lower back discomfort or the shoulder pains when I wear the exoskeleton and underbody. I do recommend that all team members who have this available, please give it a shot, see how you like it, because I have benefited from it.
far as team members wearing the exo suit, it seems to help them out quite a bit. They don't complain at the end of the day they're sore or tired. From what I've seen of them, it helps me too, because then I don't have to cover them online all the time. They're happy.
I know when I leave work, I've got a little league team that I help coach, and I have to throw somewhere between 300 and 600 pitches a week. And without this, I know that my shoulders wouldn't have felt nearly as good. As far as wearing this for PPE, I think it's just like wearing your safety glasses, your hard helmet. It's a beneficial tool for you to help relieve stress off your body.
Honest, I was really nervous there for a bit. I wasn't sure how it was going to restrict my motion or if it was at all. And it's a night and day difference. I don't have any pain in my shoulders at all anymore. If it does end up coming to your process, just give it a try. Don't be nervous. I had it down within about 2 vehicles, and then after that, it was completely a different world.
I would absolutely recommend you at least giving it a try and see if you like it. It's not going to hurt anything. It's only going to help you in the long run.
You know, they have an old saying, you can take a horse to water, but you can't make them drink. I'm one of the guys they took to the water, and man, I couldn't stop drinking. I mean, once I got this exoskeleton, I told them, hey guys, please don't ever take it from me, because this is it.
Now, I would tell you this, if any of you are planning a promotional video or future commercial, I think Sandy would definitely be the guy for your commercial. So let's take a look at the data here a little bit. On the right-hand side are some data that we've collected from one of the plants that have implemented over 100 of these exoskeleton devices. The graph shows the area where there were concerns. And you can see even injuries back in 2014. Once we put the wearable exoskeleton device onto the process, you can see that our injury rate went to 0. And I'm really, really glad to say that it's still the case today. And it's due to the wearable robotic implementation. You know, unfortunately, we are not always successful in implementing these shoulder exoskeletons. Despite all the work, we've only been successful about 50% of the time because there are some real barriers. And I take a look at dynamic work, bending in vehicle, space constraints, and even the height or reach as highlighting. And I'm going to go into some of these in detail. In this next video, you will see some examples, and I'm going to talk through the video. You can see this is actually in one of our assembly plants, and you can see the type of work that team members do. And I want to draw your attention to the variation of work, holding hand tools, grabbing parts, reaching for parts, moving along the line. You can see that we have a density within our plants, meaning number of processes or team members within a pitch of a vehicle. We do that purposely. So, you know, we're in confined areas a little bit in terms of the space and where parts are located. The other thing is the range of motion. If you take a look at, there's a reach up overhead, of course, but there's also the picking up of the parts lower. You're not in one fixed zone during the entire elements of standardized work. You know, if we look at bending in a vehicle as another common issue brought up, you know, some exoskeletons have rigid points that might scratch or chip or snag on the vehicle, and some are actually a little bit cumbersome. You know, I'm going to share 3 more important areas of concern by team members just to raise these. I think we can overcome them, but I want you to be aware of the feedback. You know, the first is thermal concerns. The gear size and the attachment schemes are noted by users as creating heat concerns, and not just in the summertime. Another is less obvious, but it's very, very real. It's the perception of wearing these devices. Will I look robotic, or will I look silly? Will I look weak, or will I look not capable? You know, these issues can be countermeasured by training, but even in this picture, if you look at the team member in the distance, how they're looking at the team member putting that exoskeleton on, you know, the picture is worth 1,000 words. Okay, next. Another hidden area is the cost and time associated with the implementation of these devices, especially during the initial deployment. Regular fittings, regular adjustments, moving techniques, and coaching are really required for success. And you know, with the COVID-19 pandemic that we all faced over the last year and to this date, you know, it's impeded the experts to be dispatched, to come over to assist, or the support to be introduced into the plants because of restrictions that we had on visitors into plants. So what's next? The challenge ahead. You know, we've had some success in these limited applications, but I want to acknowledge and thank everyone who's been involved. What you are doing every day is helpful, and I want to encourage and foster continued innovation. You know, we have 36,000 manufacturing team members in North America. That means so much opportunity for all of you to support and improve those workplaces. You know, these devices really help us. They really help our team members. And as we're stated in the video, we are counting on these consortiums like Wericon to help us innovate and collaborate and reach new milestones together. You know, when I think about the future of wearable robotics, I think about the challenges we face in the automotive industry and the excitement we face with autonomous vehicles. You know, this analogy that I want to share with all of you, I hope it makes sense. We have two different modes of autonomous driving. One is this mode called chauffeur autonomy, which is at the bottom. It's really the North Star. It's the fully drivable by a machine vehicle. You get in the back seat, you tell it where to go, it drives you there. But you know what? It's going to take a few years to get there. We know there's environmental conditions, rain or snow, redundancy in devices, the technology really to record what's going on and make the appropriate judgments. But I got to tell you, there's a guardian mode. And what the guardian mode within Toyota is adapting some of the autonomous technology into real world vehicles today. So in other words, when you think about lane assist, where you might be going to the side of the road, we have safety devices that alarm either a vibration on the wheel or a little bit of a sound that will let the driver know to get back, or pre-crash collision braking. So you come up to a vehicle that's stopped, you're not hit the brake yet, it will automatically start the brake. But those are important technologies that we've implemented as a result of the autonomous, you know, driving. So the same thing occurs with, I think, the technology we have on wearables. You know, we're going to be making continued, you know, developments, and we need to implement those, trial them, and continue to improve moving forward. We all know the ideal state, to wear something that's smart, that's adaptive, that's something that's very comfortable. It almost feels like your clothing that's on your body. Or to be inclusive. Inclusive in this term means we have thousands of different body shapes, men and women, short and tall, strength, maybe not as strong. It doesn't matter, but how do these devices adapt to all these different kinds of configurations? Now, as I end my comments today with all of you, I would like to challenge all of you to think about what our president talked to us about, starting your impossible. You know, this industry of exoskeletons or wearable robotics, as I know, started kind of in the medical channel, you know, with assisting people in special needs, then moved on to the channel of military, and now is in the industrial arena. But, you know, I'll tell you that we need your innovation. It works. Now, I want to end with a brief commercial that talks a little bit about starting your impossible. When I think about this commercial, which we showed at the Super Bowl, it was encouraging for all of us to think about and to speak to what we're trying to accomplish, not only at Toyota, but I would like to challenge this group as well.
Mrs. Long,
Yes?
we've found a baby girl for your adoption, but there are some things you need to know. She's in Siberia, and she was born with a rare condition. Her legs will need to be amputated. I know this is difficult to hear. Her life, it won't be easy. Mrs. Long?
It might not be easy, but it'll be amazing. I can't wait to meet her.
We believe there is hope and strength in all of us. Toyota, proud partner of Team USA.
Yeah, what an incredible commercial, what an incredible story. But at the core of that story is the story of human achievement. I really appreciate having this opportunity to speak with all of you today. I hope you enjoyed the comments, and I look forward to your questions as we wrap this up and begin the next segment of open discussion. So thank you very much. And Joe, I'll turn it back to you and we can start some kind of Q&A here. Thank you very much.
Absolutely. Thank you so much. That was fantastic. And the multimedia that you put together for this is probably the best I've seen in all the WearCons we've done from, and this is our 6th one. So thank you so much. I know you must have put some effort into doing that. So let me go ahead and start with the first question.
Okay.
What does the future hold for Toyota with regard to collaboration with wearable robotics industry?
Well, thank you very much, Joe. I think coming from you, that's a great question. So I just want to say that, we have a real need. In our manufacturing environments, there's a real demand for team member safety. And with that, we have a lot of repetitive motion kind of activities when we're building vehicles. As many of you know, we build a vehicle we'll just say in general, about every 60 seconds. It's not unique to Toyota. It's probably like that for our entire industry. But the key point is, how do we make assist devices that help team members? We've gotten a lot smarter about things like how to measure, how to train, how to try to avoid injury or discomfort for team members. But we really need these assist devices. I'm so encouraged to hear about things that you were talking about in space. They have application here as well. So I think it is a bright future. We've also delved into things virtual reality for training, where we put headgear on now, and it helps us to make sure that body posture is good, that we're not reaching over the shoulders without devices. But we're very, very good, and we're getting better. But to me, the challenge is getting these exoskeleton type devices that assist team members every day. So that's where we're going, and we're full steam ahead. We have a center there in Georgetown, Kentucky, where we have engineers in a lab that actually, we call it a tilt lab. And the reason we call it a tilt lab is looking at it from different angles, this technology. How can we apply it? Nothing other than that. But the key point is, it's an environment that's rich in innovation. And we use it for all kinds of things, vision systems, but we also think wearable robotics has a place in that as well, and the application in our plants. Thank you.
Great. Let me ask a question from Diego Rivera. And he says, good morning, Norm. Is Toyota implementing exoskeletons in other plants other than in North America?
Boy, that's a great question, Diego. Thank you. I can't say that I'm a global expert to know that for sure. And I wish I could answer it for you. I know very clearly that we have exoskeletons in North America region in our plants, and we've gotten great feedback. I can also tell you that we share this technology with the other regions. So just this week, Latin America, on Monday morning, we had meetings that were regional manufacturing meetings to take a look at some of the technology that they're implementing. So we have exchanges, but I can't say for sure that at what level have they been implementing. I would be very surprised if they are not implementing, especially in the Europe area, in the Asia region. and others, but I just can't speak specific to that. So sorry about that, Diego.
Great. Another question from this one is from an anonymous attendee. Norm, does Toyota have any intent to develop mobility solutions for physical disability? So in the medical healthcare market.
Well, again, I think that we've really started to look into mobility as meaning a lot of things. Autonomous driving is part of mobility, right? I mean, I can think about my own parents going up in age. A milestone for seniors is the inability to drive. That mobility that's taken away for everyday activity could be supplemented with things like autonomous. But you're talking about maybe medical assist devices, things like maybe we can wear something also to help people to rehabilitate from some kind of a serious injury of some type or things like that. I can tell you that, with the Paralympics, that Toyota is a sponsor of the Olympics and the Paralympics. And I'm proud to say equal sponsors in both, which is pretty cool. But we have actually made some of the Paralympic prosthesis for the athletes, to help them with snowboarding or different kinds of sleds and activities. So, we've done a little bit of that. I don't think it's a core business right now and things like that, but we're trying to look at and support, life for people, enhancing the life for people. So I think as technology continues to converge in all different areas, I think we could be outside the traditional realm of just car and truck manufacturing.
Fantastic. So here's another anonymous attendee. First, he or she says, great talk. And I would have to agree with that. And here's the question. Does adaptive mean in Exo's hardware or adding active motor control?
I think that adaptive could be motor control, type of thing. I think it's in both areas. I'm not sure because I think the expert that's asking me probably knows this channel a lot deeper than I do. But I'll try to simplify it in the world that I would try to understand a question like that. We want to have devices that can sense the type of work people are doing and add the assist as it's required. For instance, the early exoskeleton designs, which I wore one because I wanted to see what it was all about too in our plants. And I keep looking at you, Joe, on the side screen. I apologize, I'm not looking straight at the camera. But when the exoskeleton designs first came out, they're terrific if the work is all overhead because the mechanical advantage created a neutral position for the shoulder to be at this kind of a level. So it was wonderful. However, you saw what I tried to display earlier. When you have to come down, now you're going against the support system that's holding you up, so to speak. But can we have smart systems to know that when you're coming down, turn it off. Let that motor or whatever it is, go to a neutral to allow you to pick something up and then maybe help you support coming back up into the work region or whatever it might be. So that's my easy way of trying to answer that question. I'm probably doing no justice to the intent, but that's how I would try to do that, Joe, and try to explain the need or the necessity that we have out there. We've made great strides. I am very encouraged. And I would tell you this, that we want to collaborate with the people that are in this conference. If you have some technology, share it with us. We would like to test it. We would like to even put it in and trial it and provide you feedback and maybe even some ideas for improvement. But we know that it's going to take this collaboration together to get the outcomes that are going to be the best.
Wow. That was actually, you answering that question is very, very significant because what you are saying is that you are at least interested in looking at now censored and motor controlled exoskeletons. You're at least interested in looking at that value proposition. So
Absolutely.
that's very, very significant. Let me ask another question from an anonymous attendee. Hi, Norm. You described your experiences with Iron Hand. For everybody, Iron Hand was that hand from BioServe. Are you continuing trials with Iron Hand?
Yes, we are. So we were very pleased with the collaboration and the hard work by that team. I mean, this is very, very new. The idea, it sounds so simple, right? But the technology involved with the assist is complex. The team did a great job working with us. And when we ran this trial, we wanted to do more than one process. So as I said in the presentation, we did it on 8 different team members to get a lot of variation in terms of the feedback and the types of processes people were working on. And overall, it was good feedback. But yes, we're going to continue that. Later this summer, I would think of it as almost like a phase 2 that we're working with BioServo and Iron Hand to try to look at how the improvements are going to be better. It probably would have been sooner, but with the pandemic, it created a lot of, obviously, unexpected delay, I'll call it, right? So we're excited. We're looking forward to seeing what's going to happen with this. And frankly, to work with our team members and also with BioServo with the results, you know, to see what kind of outcomes and improvements have been made.
So Norm, let me ask another question, a follow-up. So you are doing hand exos. You are looking at shoulder exos. Are you looking at any other? Back, neck, ankle?
So, you know, I kind of highlighted the 2 big areas, and that's because they're a big focus, right, for our team members, but we are also looking at other ones too. You know, when we looked at some of the leg, for instance, you know, maybe people needed to change position a little bit. We have platforms that are movable sometimes in our plants to give different elevation ranges instead of having to move. But, you know, we have found those, what should I say, haven't been the initial focus. I think that we are open. We know that there are some probably collaborators as a part of this conference that provide those kind of devices. So we're interested. I mean, we want to learn what those are. Marisol is a part of this embedded because she uses this to understand what technologies are available and then how can we bring those into our plants. So the answer is we're not exclusive on hand and shoulder. We're open to all areas for improvement. But the one thing that I also wanted to emphasize, and I'm doing my best with the videos, the team did a great job of shooting some stuff for us as we talked about what we wanted to show. But the team members do not work in one position for the entire standardized work cycle. They're not always up, they're not always down. The range is really important. So even some of the devices that might assist with movement, if you're just kind of having a big range or a big distance, they're very difficult sometimes to meet all of those needs right now. So Joe, simply stated, we're open. We focused on those 2 areas because they're biggest to start with.
And so for all of the potential developers and sellers of exoskeletons in our audience today, what would be your final advice to them? Should they start to engage earlier than not, or should they wait until they have a product? Please.
Well, let me say this too, that within the autonomous driving area, there's collaboration within the industry. Now, people are not sharing their exact software because there's some proprietary technology, right, that is the value creation of a company. That's not what I mean. But when we think about LiDAR, or we think about radar, we think about motion detection and things, or interfacing with other vehicles that have different technologies, but how do they both react with each other? We have driving areas up in Ann Arbor, Michigan, an old an old airport that is converted now into a mini city that everybody can test their devices in, right? So even with this consortium, what I would like to say is, you know, as things start to develop and you need input, don't hesitate to ask the user group to be involved. And it could be Toyota, it could be Ford, it could be Honda, it could be Mercedes, BMW, it doesn't matter. I think you would find a willing audience because there's a willing need. And it isn't just a Toyota thing, it's an auto industry thing we're talking about. Collaboration, I think, is important so that key learning points can be understood by everybody. Both what are the needs, and then also what are some of these solutions that to overcome these needs. it could be done in different ways, but I think, is there a broad way as a coalition in an industry to help advance and get over some of these very technical hurdles? That's what I think is needed. What the end device looks like will be that innovation that you create within your company, or how you move it might be that innovation you create within the company. But I think this kind of activity that you're trying to pull together, Joe, makes a lot of sense to us about, how do we move this together quickly and fast? There's a real need. So that's maybe my message to the group. If you have things and you're thinking about it and wondering, I think reaching out to the end users, we can provide good feedback, but working together as an industry to push it ahead and make a leapfrog and think about what's possible is my final message. Thank you very much.
Thank you so much, Norm. We really appreciate your time and your insights. And we look forward to our partnership with Toyota as a user of exoskeletons. Thank you.
You bet. You bet. Thank you very much. See you all soon. And thanks for joining everybody online. Appreciate it.
Thank you. For everybody else, now what I would ask is that the next presentation will start here shortly, and that you can find that presentation by going again to your agenda, and you can see M1 medical rehab prosthetics, medical and military applications. Very interesting topic, and we really have a spectacular group of speakers. It starts at, I'm trying to convert time from my Arizona time, but at 8:10 a.m. Eastern time, so that's 10 minutes from now. Use the link here. Thank you again, and we'll see you at the next session.